Alright, so today's lesson is actually about Vernier calipers. Of the different Vernier calipers I have three different versions. I have a gray plastic, a white plastic, and a metal. They all three do the same purpose, still measure using the Vernier scale. The gray and the white ones are a little easier to actually see what's going on. The metal ones are really good because they're very rigid. However, the Vernier scale is actually about a quarter or a third of the size that it is on the gray and the white ones. The same measuring procedure is used on all three. For today, though, I'm just going to be using the white one because it shows up better on the camera. Each Vernier caliper has the same composition. So we have our fixed scale, which runs the length of the caliper, and then we have our sliding scale, which is actually on the edge here, and that's how we actually get our accuracy and precision using Vernier calipers. If we zoom in here, we'll see that our rulers or our scale actually measures in millimeters. So 0 millimeters to 10 millimeters to 20 and so forth. Then each one of these marks will represent a tenth of one of those one of the small divisions up here. Right now our caliper is actually set up at 0, 0. This 0 line is directly across from this 0 line. That's how we get our initial measurement. Our Vernier calipers are actually really handy because they can be used to measure a lot of different things. If I zoom out here a bit, we can measure objects for their length using the large size of the calipers. By sliding an object in there and then pushing up, we can measure our overall length. We can measure internal diameter. So I have this roll of tape. I can use the other end, and it's still accurately measuring the inside diameter of what's actually in the caliper, or what the caliper is actually in. And then lastly, we can actually use it to measure depth. So I have this vial here. I can actually use the metal end that protrudes to slide it down and then measure the depth. All three of those measurements move at the same rate. So at the same rate that I'm sliding this apart, I'm sliding these apart, as well as I'm sliding this out. So it all gives us the same measurement on the scale. To read our Vernier caliper, we always start with our reading from the fixed scale. So right here, where 0 is at is where our measurement's at. So as you can see, our 0 is between 20 and 21. So if we're trying to figure out what our measurement is as this is reading right now, what I would do is I would start out with 20 millimeters. All right, since we're past the 20 mark, and then now I look at our sliding scale, and what I'm looking for is what numbers are directly across. So you can see that the 0 doesn't line directly up on the 20 or the 21. We want to look for any of these other numbers that line up directly across. And as I'm looking here, the one that, to my opinion, lines up the best would actually be the 5.5 mark. So you can see they're pretty much straight across from each other. So I have my original measurement of 20, which is accurate to the ones place, and now I'm going to add 0.55 because this is actually accurate to the 0.05. That's where our accuracy and precision comes from measuring with a Vernier caliper. So 20 plus 0.55 millimeters gives us a total measurement of 20.55 millimeters. So that would be our measurement. Now let's try again actually measuring an object. I showed this spool before. Let's measure what the overall length of the spool is. So I slide my spool in the caliper, pushing slightly but not very firm, just to get a good reading. I don't want it to still be moving. I want it to be fairly rigid. So here we can see we're past the 40 mark. We're actually slightly past the 44. So on my piece of paper, what I'm going to do is I'm going to start out with 44 millimeters. That's from our fixed scale. Now we're going to look at our sliding scale. What number is directly across on our sliding scale? In my opinion, I would say that it's probably this mark right here. So 0.20 would be the mark that's directly across. So now I add plus 0.20 millimeters to my original measurement, and my total overall measurement is 44.20 millimeters, because we're accurate to the nearest 500th of a millimeter. Now let's do the same thing, measuring internal diameter. We had this roll of tape before, so let's see what its internal diameter actually is. So if I zoom out a little bit, you can see it's fit directly in the middle of our roll of tape at our widest point, because that's where we want to measure our diameter from. If we look at our fixed scale, we'll see that it's actually really close to 76. Now it's kind of hard to read with it moving. So 76 is our fixed scale reading, and then our measurement from our vernier scale that slides across. In my opinion, I would say that it's 0.80. So it'd be 76 plus 0.80, making our total measurement of 76.80. So overall, that's our use of our vernier caliper. They're very handy in that they give us gradual increments of smaller than we can even get with a centimeter ruler, therefore increasing our accuracy and precision of our measurements.